Section 8.3 Matrix Operations and their applications. A rectangular array of numbers arranged in rows and placed in brackets is an example of a matrix. The numbers inside the brackets are called elements. A matrix of order, or sometimes use dimension instead of order, n by n has n rows and n columns. If m equals n, then a matrix has the same number of rows as columns and is called the square matrix. A general element in matrix A is denoted by A subscript ij. This refers to the element in the ith row and the jth column. This chapter sections here would be a mixture of section 8.1 and 8.2 and 3. So first we'll start off with the basics of what are matrices. Example 1, let A equals 5, -2, -3, pi, 1, and 6. So the numbers in here, these are called elements. And what is the order? Again, sometimes instead of the word order, you might be asked, what is the dimension of A? And basically the word order or dimension is asking for the size of a matrix. And the size of the matrix is going to be determined by the number of rows and the number of columns. So in this example, what is the order of A? We would say the order of A is it has 1, 2, 3 rows, 3 by, and it has 1, 2 columns. So the order is 3 by 2. Letter B, identify A12. So here A12 is asking for what element is located in the first row, second column. So if we look at our matrix, we would look at the first row, which is here, and then we will locate the second column. And so we can see it's -2. So the way we write this is A12 is equal to -2. Identify A31. So in this example, we're looking at the third row, first column. So here's the third row, first column, which would be 1. Two matrices A and B are equal if and only if they have the same order, n by n, and their corresponding entries are equal to each other. And so the two definitions are the same, just written in different forms. So here we have three matrices. So the first thing to determine if they're equal is that their size of the matrix should be the same. So let's check what that order is. This is 3 rows and 2 columns. This one is 3 rows and 2 columns, and this is 3 rows and 2 columns. So the orders are the same. Now the second condition in order for them to be equal is that the corresponding entry should be the same. So in other words, this 5 has to be the same in the second matrix so that they're equal. So each one of those has to be exactly the same. So here is A equal to B. So we would check 5 is equal to 5, -2 is -2, -3 is -3, half is 0.5, 1 is 1, and 6 is 6. So all the corresponding entrants are the same. So yes, A is equal to B. Let's look at C, A and C. So here we have a 5, but C has a 3. Since they're not the same, then we say A is not equal to C. Given that A is equal to B and A is equal to this matrix and B is 1, 5, 3, 6, we want to find what X, Y, and Z are. So the only thing we know so far is that the two matrices are the same. So I'm going to rewrite them and they're equal to each other. Since they're equal to each other, we know that 1, their order is the same, but 2, the corresponding entries are exactly the same. So whatever is in this position has to be the same as this position. So here we can say that X is equal to 1. Here for Z, we have a 3, so we can say Z is equal to 3. And then for Y, we have Y plus 1 is equal to 5, so we can write the equation here and solve for Y. So y is equal to 4. Okay, so now we want to add and subtract the matrices. And so to add two matrices, the order of the matrix has to be the same. So matrices of the same order are added by adding the elements in the corresponding positions. Matrices of the same order are subtracted by subtracting the elements in the corresponding positions. A matrix whose elements are all equal to 0 is called a zero matrix, and the n by n matrix is called the additive identity for n by n matrices. So here, if we want to add these, the first thing we should check is the order. So this matrix is a 2 by 2, and this is a 2 by 2. Therefore, we can add these matrices since the orders are the same. To add them, we take the corresponding entries. So we're going to have -4 plus 6 is going to give me a 2. And then I'm going to have 3 plus a -3 will give me 0. And then 7 plus 2 gives me a 9. And last 6 plus -4 will give me a 2. Okay, letter B. The order of this is 3 rows, 2 columns, and 3 rows, 2 columns. So that means that we can add these. And so we add corresponding entries. 5 plus -4 is 1. 4 plus 8, or actually, here I made a mistake. We have to subtract. So we need to make sure that we're subtracting. So we're going to have 5 minus -4 is 9. 4 minus 8 is -4. -3 minus 6 is -9. And 7 minus 0 is 7. 0 minus -5 is +5. And 1 minus 3 is -2. Okay, so always make sure you check the operation. And then I'm gonna go ahead and add a C here. Let's say I had 1, 2, 3, 4 plus 2, 4, 5. Okay, so if we check the order, here we get 2 by 2, 3 by 1. Notice that the order is not the same. So we write undefined because we cannot add those matrices together. Objective 4, perform scalar multiplication. If we have a matrix A of order n by n and C is a scalar, then the matrix C times A is the n by n matrix given by CA. So basically, we're going to multiply everything in the matrix A by C. We call CA a scalar, multiple of A. So what this means here is if we have a number in front of the matrix, all we need to do here is multiply the matrix elements by that number. So in this case, we're going to multiply -6 times -1, +6. -6 times -2 is +12. And -6 times 8 is -48. -6 times 5 is -30. Okay, so we have 6, 12, -48, and -30. Let me just rewrite it with a little bit more space. That way it's clear that they're separate entries. Okay, so the next one, we have 3 times A plus 2 times B. Always check the orders. This is 2 by 2, 2 by 2. Even if we multiply by a scalar, it's still going to remain the same order. So we can multiply. So 3 times -4 is -12. 3 times 1 is 3. 3 times 3 is 9. 3 times 0 is 0. Plus 2 times -1 is -2. 2 times -2 is -4. 2 times 8 is 16. 2 times 5 is 10. So now we can add these together. Negative 12 plus negative 2 is negative 14. 3 plus negative 4 is negative 1. 9 plus 16 is 25. And 0 plus 10 is 10. Okay, so the next example, solve for x. So first we can look at this equation here and solve for x. So I'm going to subtract a. So we get 3x is equal to b minus a. And then I can divide by 3. So x is equal to 1/3 b minus a. Okay, so now we can plug in what we have here. X is equal to 1/3 b minus a. So we can work the parentheses first. Negative 10 minus 2. Negative 12. 1 minus negative 8 is 9. Negative 9 minus 0 is negative 9. And 17 minus 4 is 13. Then we can multiply the scalar of 1/3 inside. Negative 1/3 times negative 12 is negative 4. 9 times 1/3 is 9/3. Negative 9/3 and 13/3. Objective 6, multiplication of two matrices. So matrix multiplication, if we have these two matrices that are being multiplied, what's happening is we're going to take this first row right here, and we're going to multiply times the first column. So we would say A times E, that's right here, plus B times G. So the first one with the first one, second one with the second one, and then we add the products. And then we use the same row, but now we go on to the second column. So you want to use the same row until you're finished with all the columns. So A times F is right here, and then B times H is right here. Then we continue with the next one. Second one, C times D. So we would look at the second column first, second row, first column, and then second row, second column. The product of an n by n matrix, basically that's what I was explaining here. In order to multiply matrices, this is important. The number of columns in the first matrix has to be the same as the number of rows in the second matrix. The outside numbers is going to be your product size of the new matrix. So for example, if I had a 3 by 3 matrix and I wanted to multiply this, let's say this is matrix A, and I wanted to multiply times matrix B, which is 3 by 2, then in order to check if we can multiply is we would look at the second number, the number of columns, and the first number, the number of rows. If these are the same, then yes, we can multiply. The resulting two numbers here, that's going to be the new size of the product, size of the product after you multiply. Okay, so for example, if we want to multiply A times B here, first let's check the order. This is going to be a 1 by 3 matrix because we have 1 row, 3 columns, and this is a 3 by 1 matrix. So first we need to check if the orders are the same. Not the orders are the same, but the number of columns and the number of rows are the same. And they are, so that means that we can multiply. And the resulting size of this matrix is going to be a 1 by 1. Okay, so I'm going to go ahead and write the two matrices here, 1, 2, 3, and we're multiplying this times negative 2, 0, 1. And so first we look at the first row with the second column. So we have the first number, 1, times the first number, -2, plus the second number times the second number, and then the third number times the third number. So -1 times 2 is -2. This is 0 and then 3. So -2 plus 3 is 1. So our resulting matrix will be equal to 1. And again, here you can see that this is a 1 by 1 matrix. Let's check letter B. So for letter B, the size of matrix B again is 3 by 1. And for A is 1 by 3. So we can multiply because the inside numbers are the same. So we can multiply. And our resulting matrix should be a 3 by 3. So here we're going to have B times A. And this is going to result in a matrix that has 3 by 3 matrix. Okay. So to begin, we look at the first number or the first row, which is this one, and we're going to multiply times the first column. So we would say -2 times 1, and there's nothing else in this column, so my answer here is just -2. And then we go on to the second column. -2 times 2 is -4. -2 times 3 is -6. And there's no more columns, so that means we can move on to the next number, which is 0. So we start the same process, 0 times the first column, which is 1, that's 0. 0 times the second column, so 0 times 2 is 0. And then 0 times the last column, which would give us a 3. And then last, we want to multiply the 1, so 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. And so here is a 3 by 3 matrix. Okay, so let's go back to the handout. So given A 1, 3, 2, 5 and B 4, 6, 1, 0, find the product if possible. So again, first we need to check if the orders are the same, not the same, but the number of rows and columns are the same. So here the number of columns and rows are the same. So this is going to be, we would be able to multiply. The resulting product will be a 2 by 2. So once we're done with multiplying A times B, we should have a matrix that is a 2 by 2. Yep, so let's go ahead and multiply these. We have 1, 3, 2, 5 times 4, 6, 1, 0. So first, we look at the first row and then the first column. So 1 times 4, so we would have 1 times 4 plus, notice there's another number in that column, so we're going to have to say 3 times 1. And so we add this, 1 plus 4 is 4, 3 plus 1 is 3 times 1 is 1, so that will be a 7. So that's going to be our first entry here. So then we still use this same row with the next column. So 1 times 6. So 1 times 6. And then 3 times 0. And so my answer here is 6. There's no more columns, so we go on to the next row and we start the same process. 2 times 4 plus 5 times 1. So 2 times 4 is 8 plus 5 is going to be 13. And then the last column, 2 times 6 is 12 plus 5 times 0. So my result here is 7, 6, 13, and 12. Okay, so the next one, B times A. We check the order. So this is a 2 by 2 times a 2 by 2. So yes, we can multiply. So we're going to have 4610 times 1325. So we would say 4 times 1 is 4, and 6 times 2 is 12. So 12 plus 4 is 16. 4 times 3 is 12, and 6 times 5 is 30. So if we add 30 plus 12, we get 42. Go to the second row, 1 times 1 is 1, 0 times 2 is 0, so we get a 1. 1 times 3 is 3, 0 times 5 is 0, so we get 3. Let's go on to example 9. So the order here for the first matrix is 2 by 2. The second matrix here is 2 by 4. So these are the same. So that means that when we're done multiplying, we should have a matrix that is a 2 by 4. So I'll have a number here, one here, and one here. Okay, so if we multiply this, then it would be the first row, 1 times 2 is 2, 3 times 0 is 0. So my answer would be 2. 1 times 3 is 3, 3 times 5 is 15. So the answer there would be 18. 1 times -1 is -1. 3 times 4 is 12. So my answer is going to be 11. And 1 times 6 is 6. 3 times 1 is 1. So we get 9. And go ahead and try the rest. These are the numbers you should get: 0, 10, 8, and 2. Okay. The last example, we have 2 by 4 and 2 by 2. Notice that the first inside numbers here are not the same. So we write undefined because we cannot multiply. Okay. You can put this in your calculator if you have a graphing calculator. To do this on the calculator, you would have to go to second matrix, and then you're going to edit a matrix. You enter the first matrix. So let me go ahead and enter. Let's do this one. So A here is 1, 3, so that's a 2 by 2 matrix. So I'm going to enter 2 by 2, and so it changes the matrix size. And so for A, we have a 1. And then we have a 3, a 2, and a 5. So then I'm going to go ahead and second quit, and I'm going to do it again, second matrix, and I'm going to edit, but this time I'm going to choose matrix B. It is a 2 by 2 also. And then I'm going to go ahead and enter those numbers: 4, 6, 1, 0. And so then now if I check them, notice I have my two matrices here. So now we can go ahead and do any operation. So let's say we want to add these, then we would say second matrix. I'm going to call A plus second matrix. I'm going to call B. Then I press enter, and so then that's our result. Okay. If we're adding. If you want to multiply, then we would have second matrix A times second matrix B. And so then you can see we get the same answer: 7, 6, 13, and 12. And so that's how you would use your calculator if you have one. All right, so the last part of this video is just to talk a little bit of section 8.1 and what is an augmented matrix. So basically, an augmented matrix has a vertical bar separating the columns of the matrix into two groups. The coefficients of each variable are placed to the left of the vertical line, and the constants are placed to the right. If any variable is missing its coefficient, then we use 0. Okay, so for example here, we would have a bar separating the left and right part. On the left side, we write the coefficients. So I have a 3 for x, a 1 for y, a 2 for z, and my constant is 31. And I keep doing that 1, 3, 2, 25. And so this is your augmented matrix. On this side, we have a 1 for x, a 2 for y, -5 for z, -19 is your constant. Notice there's no x, so I'm going to use 0. And then we have a 3 and a 9. And then for x is 0, y is 0, z is 1, then we have the 4. In the next video, we'll be able to do operations with these augmented matrices.